Welcome to our asynchronous compost making course, part of the demonstration series produced by the Extension, Training, and Information Division. Throughout this course, you'll explore the science of composting, a sustainable process that turns organic waste into nutrient-rich soil. Whether you're a beginner, farmer, or an industry professional, you'll find valuable insights to enhance your composting practices. Join us on this journey and empower yourself. Let's get started. At the end of this course, you will learn key principles of composting, various composting methods, the skills in crafting well-balanced compost recipes, how to identify and address common issues, insight into the versatile applications of compost, and the environmental benefits it offers. This course is comprised of 7 modules. You will be required to review all 7 modules over the next 4 weeks. To receive your certificate at the end of this course, you must complete the assessments using what you have learned. The following modules will be covered. Module 1, Introduction to Compost Making. Module 2, Composting at Home. Module 3, Farm-Focused Composting. Module 4, Industrial Composting. Module 5, Vermicomposting. Module 6, Harvesting the Fruits of Composting, Putting Knowledge into Practice. Module 7, Compost Tea, a Success Story. Module 1, Introduction to Compost Making. In this subsection, we will cover the following subtopics. What is composting? Composting ingredients. Composting process. Composting techniques. Troubleshooting compost. And the benefits of compost. Let's explore the concept of composting. Composting is the process of recycling organic matter, such as leaves and food scraps, into a valuable fertilizer that can enrich soil and plants. It speeds up the process by providing an ideal environment for bacteria, fungi, and other decomposing organisms, such as worms and nematodes, to do their work. The resulting decomposed matter, which often ends up looking like fertile garden soil, is called compost. To ensure effective composting, it's important to use a variety of materials and maintain a balanced carbon-to-nitrogen ratio. Carbon provides energy for microorganisms, while nitrogen is vital for building proteins that help these microbes grow and function. Shredding or grinding raw materials speeds up composting by increasing surface area for faster decomposition. Common materials used in composting include brown organic matter, such as dry leaves, straw, and wood chips, is rich in carbon. Green organic matter, such as food scraps, grass clippings, and manure, all rich in nitrogen. Let's consider additional factors necessary for effective composting. Water. Water is crucial for the microorganisms within the compost heap to thrive and propagate. Their activity diminishes in overly dry conditions, while excessively wet environments favor anaerobic organisms. Ideally, compost piles should maintain a moisture level between 40% to 60%. This means they should feel slightly moist when touched, yet dry enough that a firm squeeze produces only a drop or 2 of water. Good microbes. Fungi, including molds and yeasts, decompose complex plant structures in compost. By breaking down tough materials, they facilitate further decomposition by bacteria, which generate heat and primarily decompose simpler compounds in compost. Air/oxygen. Turning the compost pile provides essential aeration for the microbes present. These microorganisms rely on oxygen to convert organic components into compost. Insufficient oxygen leads to the dominance of anaerobic bacteria. Ideally, oxygen levels in the heap should range between 10% to 14%. Understanding the items to avoid in your compost bin is crucial. Meat or fish products, slow to decompose and attract pests. Dairy products, for example, butter, cheese, mayonnaise, salad dressing, milk, yogurt, sour cream. These would smell, take a long time to decompose, and attract pests. Oils, grease, or fats of any type, slow to decompose, will putrefy, smell bad, and will attract pests. Glossy paper. The inks are usually toxic and contain heavy metals, dyes, and pigments. Chemically treated wood products. Charcoal and briquettes contain sulfur and amp, other chemicals that are toxic to soil/plants. Diseased plants. Weeds with seeds. Heavy metals, for example, lead and mercury. Human and pet animal feces may contain pathogenic bacteria, viruses, and parasites. For optimal composting, ensure a balanced carbon-to-nitrogen ratio, 25:1 to 45:1, by mixing materials accordingly. Green, nitrogen-rich material like grass clippings and food scraps speed up decomposition, while brown, carbon-rich materials such as leaves and straw enhance texture and moisture retention. The above illustrates a list of common compost materials with their estimated carbon-to-nitrogen ratio. To create a balanced compost mix, a general rule is to combine 3 parts brown materials with 1 part green materials. For example, if you have 3 buckets of grass clippings, totaling 45 units of nitrogen, and 1 bucket of corn stalks, totaling 60 units of carbon, the total mixture equals 105 units. Dividing the total by the number of components used, you achieve a ratio of approximately 26:1, which is conducive to effective composting. There are 2 types of composting: hot and cold composting. Hot composting is a fast and efficient way to decompose organic materials by maintaining high temperatures within the compost pile. This heat is naturally produced by thermophilic microbes as they break down a balanced mix of nitrogen-rich, green, materials and carbon-rich browns. For successful hot composting, you'll need a proper balance of greens and browns, carbon-to-nitrogen ratio of about 25:1 to 30:1. Regularly turning to ensure good airflow. Moisture levels similar to a wrung-out sponge. This method speeds up the composting process, often completing in just a few weeks to a few months, and helps destroy weed seeds and harmful pathogens, resulting in dark, crumbly, nutrient-rich compost. Cold composting, for example vermicomposting, is a slow, low-effort method of decomposing organic materials at ambient temperatures. It doesn't require turning or managing heat. Instead, mesophilic microbes, which thrive in moderate temperatures, do most of the work since they cannot survive the high heat. However, it doesn't get hot enough to kill weed seeds or certain pathogens, so care should be taken with what you add. Let's explore the composting process. 1. Preparation. Collect diverse organic materials such as food scraps, dried leaves, grass trimmings. The materials you use should be chopped or shredded into small pieces to speed up decomposition. 2. Layering. Place the organic waste in a compost bin or pile, alternating between green materials, like food scraps, and brown materials, like dried leaves. 3. Moistening. Add water to the pile to keep it damp, like a wrung-out sponge. 4. Turning. Periodically turn or mix the compost pile to aerate it and speed up decomposition. 5. Decomposition. Over time, organic materials are broken down into compost by microorganisms in the presence of oxygen, releasing heat as a byproduct. Use a compost thermometer or simply feel the temperature with your hand to monitor the temperature of the pile. 6. Maturation. Allow the compost pile to mature over time. During this stage, microbial activity slows down and the compost gradually stabilizes. After several weeks to months, the compost matures into a dark, crumbly substance that resembles soil. Finally, harvesting and use. The compost is ready to use when it is significantly reduced in size. It is no longer hot. It appears brownish to black. It has a crumbly appearance. By following these steps, you can effectively compost organic materials and create nutrient-rich compost for your needs. Now we will examine some common composting techniques to effectively manage organic waste and create nutrient-rich compost. Each composting method has its advantages and is suitable for different situations. Indoor composting involves using specialized bins or containers to compost organic waste inside your home. Suitable for apartment dwellers or those with limited outdoor space. Kitchen scraps like fruit and vegetable peels, coffee grounds, and eggshells are collected along with shredded paper or dry leaves to maintain a balanced carbon-to-nitrogen ratio. Regular mixing or stirring provides oxygen to the microorganisms, facilitating aerobic composting. Heap or pile composting involves placing organic waste materials in layers to form a pile in a suitable area. Green materials like food scraps and grass clippings are alternated with brown materials such as dried leaves or straw to create layers. This method requires occasional turning or mixing of the pile to aerate and maintain high temperatures. Windrow composting involves forming long rows or windrows of organic waste materials in an open area. Green materials like kitchen scraps and yard trimmings are mixed with brown materials such as leaves or wood chips. This method efficiently decomposes organic matter by using long rows that generate heat. The windrows are periodically turned or aerated to provide oxygen to the microorganisms responsible for decomposition. Vermicomposting involves using worms to break down organic waste into nutrient-rich compost. Special bins or containers are filled with bedding materials like shredded paper or cardboard, along with kitchen scraps like fruit and vegetable peels. Worms, such as the African night crawlers, are then introduced into the bin. These worms feed on the organic waste, breaking it down into castings or worm poop, which is a valuable fertilizer. The slide you're viewing highlights various composting challenges and potential solutions. Compost is usually spread over the soil and can be worked into the first few inches. Never put plants in pure compost as they need coarser particles like soil and sand to be able to properly root. Compost serves multiple purposes. Top dressing. It is applied to the surface of soil where plants grow, serving as a protective and nourishing layer. Soil amendment. Compost enriches the soil by improving its structure, water retention capacity, and nutrient content. pH balance. It helps maintain the optimal pH level for plant growth, promoting healthier and more resilient plants. Versatile use. Compost can be applied to various areas, including lawns, trees, shrubs, vegetable gardens, and potted plants, providing benefits across different types of planting environments. Compost offers a multitude of benefits, enhancing soil structure and promoting water retention and slow nutrient release. Acting as a natural mulch, it suppresses weed growth and reduces soil erosion. Moreover, compost sustains the intricate soil web, fostering a healthy ecosystem underground. Additionally, it plays a vital role in carbon sequestration, locking carbon into the soil and aiding in mitigating climate change.